Okay, hello everyone. My name is Michael Cwienczek. It's best if you want to look me up in the internet, just use my last name. It's unique. Nobody has this. There's only few people in the world that can that have the same name, and nobody can pronounce it anyway. So I'm going to be talking about Kubernetes for developers. This is going to be introduction to Kubernetes, basically. So we will be talking about from the very beginning. So what is Kubernetes? And then we will build this up until Q&A, where actually we will open it to wider discussion, where maybe you have some more advanced questions that I can answer. That would be also cool. Let's start with this. Who from you knows what Kubernetes is? Okay, so like half of the audience. Okay, and who uses Kubernetes or used Kubernetes in, not in production, but at work, basically? So, okay, cool, nice. So let's start with introduction, but you are not here for introduction. So I just pasted here a definition of Greek word Kubernetes, which comes from Greek. You can Google it as well. But basically it was created by Google, open sourced, based on internal Google project called Borg in 2014. Yeah. So let's go a little bit back in time and let's see how we used to host or deploy applications before that, before Kubernetes or containers were cool. So first we have traditional deployment, where basically you have your server, you installed Windows or Linux on it, and then you put application into it, right? Then it started becoming a little bit more advanced or virtualized. Somebody came up with the idea to detach the hardware, physical hardware, from the virtual hardware, you can call it. And they started hosting virtual machines that gave you a little bit more portability, right? Because you could clone the machines, you could easily restore the image. So that enabled you to work a little bit easier with all of your deployments, applications, with your environments, with the reproducibility of the environment and all that stuff. And then the revolution came when actually containers came to life. Because somebody also came up with the idea that why do we need to clone or take the image of the whole virtual system? Let's just take the parts that we need. Let's keep them or copy them into our small things that we call containers, and let's use them. And this way, we are kind of semi-independent from the operating system and hardware. But also we have those lightweight things that we can host on top of them. So that is a simplification, oversimplification. It goes into deeper complexities in it, but this is the story more or less. And then after Docker and after containers, Kubernetes came to life. And what Kubernetes did, this is what Kubernetes does. So I will talk about what Kubernetes is just in a moment, but this is the problem. You have applications, you have 9 applications, and you need to put them into 4 VMs, right? And in the old days, you would need to deploy it here or here or here or here. And whether you use virtual machines or use physical hardware, you would need to do it manually or semi-manually. And what Kubernetes does for you, you say, deploy those applications for me, and Kubernetes does this. And it's deployed. It selects one of those machines for you, and it will also do a lot of different calculations, like where do you have space, where do you have memory, where do you have more processor power, all that kind of stuff. And it will distribute those applications across those machines. That is basically the idea of Kubernetes. And what is Kubernetes? It's a lot of things, and it has this is non-exhaustive list, by the way, but basically Kubernetes is just a set of applications. Those are just applications. This is no magic, right? So you have services running on those machines, and they communicate with each other. There's also a control plane, which orchestrates all of this. So those, and this set of applications, because it's kind of, Kubernetes in itself is kind of component-based application. So there's lots of components to Kubernetes. We are not going to discuss the details of how components work with each other, because this is not necessary for developers, I think. And you are developers, I think, right? So I just listed things that you can do thanks to Kubernetes, and you can do them easily. So you can have unified deployment across your whole cluster. Cluster is a list of VMs or just a bunch of VMs. You can have even, you can define unified deployment across the whole department or the whole company. You can have automated restarts, automated kind of self-healing capabilities where your applications, when they die, they will try to self-heal themselves, so try to go back online if you need them. You can achieve high availability, which was pretty difficult to achieve before the world of Kubernetes. It was much more difficult to do high availability. You can save cost because you can put multiple applications in one machine. So you basically spread it, but you also can put multiple applications on top. So you efficiently use the processing power that you have. It's cloud agnostic. You can deploy it to Google Cloud, to Azure. You can also deploy it to your data center or even Raspberry Pi. You can have Kubernetes on Raspberry Pi these days. Yeah, and that's it. And there's actually much more, but that's enough, I think. And this is how Kubernetes cluster looks like. So there are, as I mentioned, there are worker nodes, which are used to schedule workloads. So basically, your applications will run here. And there is master node that mostly does distribution, storage, state storage. It stores the state of the whole cluster. So basically, it stores what is the state? I'm trying to be, I'm trying to use also developer terms a bit. So basically, it stores the information where your application was recently running. That's what also master nodes do. And now I will discuss a few basic building blocks of Kubernetes, because those things you need to know if you want to work with Kubernetes. So the first basic unit is pod. And the pod is just a bunch of containers. So you can have pod with one container, but you can also have with multiple containers. And all of those have shared IP. They run always on the same machine. So this is the unit that Kubernetes deploys. So Kubernetes does not work with containers directly. You have to define them, or you have to package them in a thing called pod. And then Kubernetes will make sure that it runs somewhere on one of the machines. It shares network, and all those containers, they share the same life cycle. So if one dies, all of them die. Or all of them restart. Let's put it like this. Questions so far? Okay, cool. Let's go. So this is, yeah, I basically described this briefly before. So you have so-called workload allocation. That's basic feature of Kubernetes. So this is a little bit different from the previous one, because here this is one application, and this is second application, and this is third application. But you have 3 replicas of this application because you want to achieve high availability. Or you need, basically one machine is not enough to host all your, let's say you have millions of requests, right? And one machine is not enough to handle your load. Then you need multiple replicas of your application, right? And then you need to spread them over machines. And that also is something that Kubernetes does. So let's say that you have one application with 3 replicas, second application with 2 replicas, and third application with 1 replica. And Kubernetes will magically just throw them in one of those machines. And it also sometimes, depending how you define it, sometimes they can put the same application twice on the same machine, but sometimes you can spread it. So those are the things that you can define and configure in Kubernetes as well. Now, quick kind of demo. What happens when pod dies? So pod is one of your application, right? So we have this kind of situation where applications are running, they are serving your traffic, and one of the applications dies. Like, let's say this one has an error or something. Kubernetes will detect this and will try to restart it over and over again and try to make it to the state where it works again. Now, if we have a situation where the whole node, which means virtual machine, dies, so basically there is hardware problem, I don't know, CPU got fried because somebody cooked on it, I don't know. Like, if one machine dies, Kubernetes also will detect this and will make sure that your applications are spread among the ones that are remaining. So they will be moved here. They won't be technically moved, they will be started, new applications will be started here. But that's what Kubernetes does. I hope it's still clear, everybody can follow, yeah? Cool. Question?
Yeah, one of these can be a master node, right? What happens then?
If the master node dies, usually you run master nodes also in 3 or 5 or even more master nodes. So if one dies, there's still 2 master nodes that can take over. What is a deployment? This is, again, basic building block of Kubernetes. Deployment is something that you use to define that you want 3 replicas of your application. So you have deployment, you want 3 replicas of your application, which is WordPress in this case. And the deployment, if you create a deployment, it makes sure that 3 replicas, in this case 3 replicas of your application, of the pods will run. It will try to make sure that they always run. So there is this reconciliation, it's called mechanism. So Kubernetes will always try to make sure that the applications are running in the same way that they are that you have defined them. So in this case, you define them as 3 replicas. That's oversimplification, but there are more parameters to this. But basically, you want your applications to be running in 3 replicas, and Kubernetes will do its best to make sure that those 3 replicas will work. And that's why I described those scenarios. So if one node dies, it will still make sure that 3 replicas of your application works. If one of your application dies, it will also make sure that this application gets restarted somewhere else, so that always 3 applications are running. Now, there is a question?
By somewhere else, or can it also restart the application on the same node?
Yes, if the node is healthy and it's running, it can restart on the same node, yes. Now, what is a service? Service is a virtual thing. It doesn't actually exist, but we're not going to go into that detail. Service is something that you also create in Kubernetes, and it does load balancing across your pods, and it also does internal DNS resolution inside the Kubernetes cluster. So if you want pods or something to communicate to your applications, you need to create a service. And then there is an Ingress. And Ingress is something that you create if you want someone from outside of the world, outside of the cluster, let's say, I don't know. You have users from all over the world, right? This is not internal application to your company. You have users from wherever you want. You need to create Ingress, and Ingress is like entry point to your cluster that you need to define in order to connect to your services. And that's what you need to know, I think, at this point. This is a little bit difference of Ingress versus service. So here you can see that with Ingress, user can connect via service to your application, but if you have service only, you can use it only between one application to the other. So this is kind of how it works. What's the difference between Ingress and service? So this one is needed if you want to have, it's technically not needed, you can do it in other ways, but usually how you do it, you create Ingress that enables you to access services inside your cluster.
In which cases would you use only service without Ingress?
When you have intra Kubernetes communication, right? So if you don't have external user, you have two applications, microservices, let's say, right? And you want them to connect to each other, you will use service. So you will basically use service to connect between them. So you need to define service so that they can connect like this. Okay, let's create first application. We will deploy deployment, service, and ingress, and we will see how that works. And then we will add some more details to it. So this is demo time. Yay. Any questions so far? No? No questions. Okay. There will be also space for questions that are outside of this presentation. So if you have questions about Kubernetes or something, I hope I can answer them later. It's a little bit small. Yeah, let's do it like this. I have prepared a very simple Node.js application. Why Node.js? Because I love it? No, I'm kidding. Basically, it was easy to create, and it's great for this demo. I have created very basic application that does only one thing. When I deploy it, it should show you this HTML. So simple web application is online. It will tell you what kind of environment we are running in, what is inside the config.json, and what is the database password. Ooh, we shouldn't be showing this to users, but yeah. So let me deploy it. I have already Dockerized this, so I will not go through building the image and all that stuff. I will just deploy it. I already started my local cluster, so I have Minikube. If you are interested, you can download Minikube and run it on your own machine. And let's start with deployment. That's how you basically deploy your application. Let me show you as well how it looks like. So this is deployment. This is the thing that we defined and I showed you in the previous slide. So the most important thing is the kind. It's deployment. It has a name and it has replicas. And apart from this, it also has a name of the Docker image, so the name of the application that you are running. And that's it. I don't want to go into details right now. I think that's all you need to know to be able to use Kubernetes as a developer. So let's deploy this application. I already deployed it. It's defined in YAML, by the way. So everything in Kubernetes is defined in the YAML language. So this structure is the default, and you cannot use any other structure. Let's say, so Kubernetes only understands YAML, so you need to define your files like this. And then you use either kubectl or some other tools that probably your company will provide, more advanced tools that you can use to deploy your applications. But in general, you use YAML, and the YAML gets interpreted or parsed by Kubernetes so that Kubernetes knows what to deploy and how to deploy it and how to manage your application. So with that, let me see, kubectl get pods. As you can see, my application is running, and it's running in 5 replicas, exactly as we wanted, right? And I can show you something. This will be small, but let me do it like this. I will do something. So on the left, we are watching the state of the cluster. You see, this is the age of those containers. It's running all the time. We are refreshing this screen every 100 milliseconds. And now I will try to kill one of those applications, and we will see what will happen. So I'm killing one of those. You see, this one was terminating, but there was already another one. It's very fast. So there was another one that said container creating. It was very fast, but let me do it once again. This one doesn't exist, so let me find another victim of our experiments, this one. Again, one is terminating because we killed it, and the other one started immediately. So that's a very basic demo. So that's what Kubernetes does. If you kill one of them, it will always make sure that 5 are running. Okay, but that's on a side note. Let's go back to the demo. So the application is running. Let me confirm. I will do something called port forward. We don't have port. Let me do this. This one. And we are using port 8080, I believe. Yeah. This is the application, right? This is what we defined in HTML. So the application is online because it says so, right? It must be true. Your environment is no idea what environment, because we didn't define it in the deployment. There's some config JSON which is empty and password is missing. So yeah, we have some fixing to do. So the second thing we want to do, we want to add configuration to our application, right? That's the first thing you do. You cannot run application without configuration. You always need some kind of configuration for your application. In this case, we will add configmap. Configmap is Kubernetes thing that stores things that are key value pairs. Those are configuration elements. And they are mostly used for non-sensitive data. So don't store passwords in them. There's another thing called secret. I will talk about it in a moment. That is designed for secrets, for your passwords, database passwords, and so on. So, config map. We need a config map because our environment is empty. So, I will create, let's go here. This is a config map. It's a very simple one. This is also YAML, as you can see. And it is kind of key value pair. This is a key, this is value, right? So it is kind of a key value pair. And this config map is, again, YAML. It has a name. And we need to deploy it. So we need to push it, deploy it, whatever you name it, to Kubernetes so that Kubernetes has information that this thing exists and this is in Kubernetes. So if I do kubectl apply config map was created according to Kubernetes. And if we do kubectl get config maps, we should see it, yes. We see also another config map, but this is Kubernetes related. Let's skip this. So we have our config map. Now we need to change our deployment. We need to mount. We would like to mount this config map as a file inside our container. So the config map that we just deployed, that has inside key called config.json, will be mounted in the container as at this path, exactly at this path. So I have uncommented this code. And now if I do kubectl apply again to our deployment, another magical thing that happens. If I change the deployment and I do this, apply-f deployment, it will change my configuration of the application in the Kubernetes, and Kubernetes will do everything it needs to do to change the configuration of your application while running, ideally. If not, it will restart the application and try to configure it anew. So in this case, I believe we will see that the application gets restarted because the config map needs to be attached. What is this? I forgot this one. Yeah. So anyway, we are mounting. I'm not going to go into details about volumes. The goal of this for me is to show you what Kubernetes can do, and I'm sure you can go into details either later or via Google or do some course. There are more in-depth courses. Of course, we cannot do everything in, like, I don't know, 1 hour. Yeah, we have 1 hour more or less. So I am mounting this application, this config.json into the container that will be running. And as you can see, I quickly type the command so that we can see that this is the new application that will be created and it will mount the configuration JSON that we created. And those applications are gracefully terminating. So one by one they will be killed and the new ones will get created. And if I do kubectl get pods now, you should see all of new ones running and all of the old ones are terminating. And now if I do the same magic, I do port forward. Port forward is the thing that container name changed. Port forward is a magical command that enables me to connect to the container without going through the internet. So this application is not accessible via the internet. Like I described, you need Ingress for this and service and all other stuff. This is kind of a hacking way so that I can connect to the container without those things. So I am port forwarding again. I am refreshing the screen. And yay, we have some configuration. So we just injected configuration into our container running inside Kubernetes. Now, let's do something more. So we still need to, what do we need to do? Secret. Also, key value pairs, it's very similar to configmap. The only difference is that you should store secrets in there, yeah, like the name suggests. And they are encrypted. And they can contain arbitrary data, so it doesn't need to be password. It can be any text, whatever. So, as it turns out, I already have a secret here defined. And we will inject this secret, the database password, as environment variable inside the Kubernetes container. And also, we will do, by the way, we can do this, which is, we can also provide explicit environment variables. So if you don't want to use secrets, or you don't want to use like mounting volumes and config maps and all of this stuff, you can simply define your environment variable directly in the YAML file. So this value environment will have value production, and it will be injected into the container after it restarts as well. But apart from this, we have database password. We uncommented this, but we didn't create a secret, right? So here is the secret. There's a database password. So let's apply it. So we need to deploy it to the Kubernetes again. So let's do secret.yaml. Bam, created. Now, okay, let's check. Let's check if it's really there. Okay, it's there, database password. Now, we apply deployment again, and deployment will restart. And it's running. 9 seconds, 7 seconds. The old ones are killed. And we can see, once again, let's do the hack. Let's connect to one of those new containers. And let's see that the password and the environment are set. Yes, we have random database password. Don't copy it, it's very secret. And environment is production, apparently. So that's how you can inject values, configuration, environment variables, and files inside Kubernetes, inside your application. Now, you want your service to communicate with each other, right? So we need a service. I described it before. You need to define something like this. It has this thing called selector. This thing, it was, when I started learning Kubernetes, it was very confusing for me. But this thing here, the app, the selector, and the app equals web app. I can zoom in even more. Do you see from behind? Is it? Okay, cool. So this thing, app equals, or colon web app, needs to be the same as the Kubernetes, as the deployment label. So it needs to match this one. Actually, this one. So when you create your deployment, it needs to match the label here inside your definition. And that's how you connect service to the deployment. So deployment has a label, service says, okay, let me create, how to say this? Let me allow connection to all the pods with this label, right? So that's how it works. That's how you connect them, via label. So let's create the service. There is, of course, protocol, port, all the normal stuff. Service was created. Now we can see that there is web app service, and now we need to port forward to it. So, because again, let me go back to the slides. This one, once again, you have a service. You can connect from one application to the other, but you cannot connect from outside. So what I need to do now, what I did till now, is I connected directly, like I kind of hacked into the application so that I can make requests here, directly here. Now I will hack into service, let's say, from outside, and I will try to make requests, HTTP requests here on the service. Technically, you won't see a difference now because it will just show the same website, but technically we will hit the service or we will go via service. So kubectl, port forward, and now we do svc/web app. I have it here. And now we need to change port because the service port is 8081, as you can see. I did myself this service and I changed the ports. And now it's running on port 8081. But again, this is only from inside the cluster. This is not exposed to the outside. So, and it's working, right? It's working, yeah. So let's do Ingress, right? So the last thing that is left is we need to create Ingress. Once again, I will go back to the slide. So now we will create this thing, Ingress, so that the user from outside actually can see the application. So now we will do without any hacking into services, apps. We will just use IP of my machine or the Minikube IP to actually see the application. So there need to be other things deployed, but this is more for SREs or your DevOps team. So DevOps team needs to deploy something called Ingress controller for Ingresses to work. But this is not for developers again. So I'm focusing on development cycle here. So let me go and deploy Ingress. And the same thing happens here. As you can see, we can match them via service name and also the port. So as I mentioned before, the connection between service and deployment, how service knows which deployment or which pod to connect to hit, it was done with labels. Now it's not done with labels, it's just done with the service name itself, but the principle is the same. So if you have an Ingress, you define a Ingress class name, those are blah blah blah. You have some rules, HTTP, which paths do you want to hit? So we want to basically respond on any path, starting from /. Those are things that you always need to define, backend service, and then what's important is this thing. So this thing tells your Ingress that you want to connect to this service that we created here with the name web app. That's how they connect. This is the most important part. Okay, let's deploy the service. I already have Ingress controller, by the way. So it should work. Okay, and now let's check kubectl get Ingress. Yeah. Oh, we even have IP address. Let me see if it works. Not like that. So, yeah, it works. Surprise. Yeah, I'm also surprised sometimes. Yeah, so those are basic building blocks of Kubernetes. Deployment, service, config map, secret, Ingress. That's what you need to know as a developer if you want to start with Kubernetes. And I think I was supposed to scale the app as well. I can do that, sure. So let me go again. Let me do this nice fancy demo. So we will split the screen again. And And here we will do watch. So we will see the pods running. And here I will do something like kubectl scale deployment web app, I believe was the name. Let me check. The deployment name was web app, yes. Replicas equal 10. So we are scaling from 5 to 10, the application, right? Bam. And we have 10 applications running. And you can also scale down. So if you don't need so many applications, you can scale to one replica. And almost immediately everything gets killed, and you get this one. You see, Kubernetes has chosen one. So basically there is this chosen one that's still running, and the other ones are killed by Kubernetes.
And the original 5 stayed, or?
No. Now we basically changed the deployment. So this, what I did with scale, it's equivalent of doing this. I change this to 1, and then I do kubectl apply-f deployment. And this is the same thing. And now nothing changes, there is still 1. If I change this to 5 again, and I do apply, it's again creating 5. So, yeah. That's how it works. What else? Yeah, this thing I'm not going to show. This is a little bit more difficult, and we don't have time for this today. But Kubernetes can scale on even arbitrary metrics. So, for example, I don't know if I think I can say this. I hope Antonio won't sue me for the NDA. But we had a problem with scaling, for example, Node.js applications. And one of the things we wanted to do, I don't know if we actually finished this or not. I don't know if this was done in my time or afterwards. But there was this Node.js application that was not scaling well on CPU and memory. And basically, what's the problem with Node.js application? That it's single or actually 4-threaded application. And the difficult part with Node.js application when you receive requests or when you have high load is that Node.js application is not actually CPU or memory bound. Node.js applications have this thing called event loop. And when you have too many requests or there is too many things happening inside Node.js application, the internal event loop will get full. And your requests will not get processed anymore. And in Kubernetes, you would see everything is fine because CPU is fine. It's not using much CPU. It's not using a lot of memory, so you don't scale on memory. But the application cannot handle the load anymore. So what's happening? So it turns out that you should also monitor event loop queue inside your Node.js application. And this way, you can, for example, scale better your application. So those are development details that you also need to know if you want to scale your application properly and well. But those kinds of things are also not out of the box, but they are possible with Kubernetes. So you need a few things. You need a few additional components. But what you can do, you can even scale your Node.js application based on event loop, queue, or something like that, or any arbitrary metrics. You can scale it on amount of requests you receive in a second, but that's pretty, maybe not easy, because you also need some external custom configuration, but it's something that I guess you could figure out by yourself, right? The tricky part was, for example, with the Node.js application that we had. But by default, once again, by default, Kubernetes supports CPU and memory scaling. So if that's all you need, you have .NET application, you can scale on CPU and memory. So what do I mean by scaling by CPU and memory? What I mean is your application is using, let's say, 1 gigabyte of memory, and you can configure Kubernetes that if you exceed 1 gigabyte, Kubernetes will automatically create another replica of your application. And then if another application, or actually all of them, exceed 1 gigabyte, another one will be created. And then when they exceed 1 gigabyte of memory, another one will be created. So it's automatic scaling based on memory and CPU, yeah.
Does it also downscale after?
Yes, yes it does, yes. And you can also tweak it. Some things we couldn't tweak without actually getting into very Kubernetes gory details and configuration of the components of Kubernetes themselves. But the basic configuration, and I think all you need can be configured with the YAML file. So you deploy a specific YAML file, there is your scaling configuration, the maximum, the minimum, and then it just goes up and down as you have your load. That's it, thank you. Thank you. Questions? Yes?
In one of your earlier slides, you showed pods is a collection of multiple containers.
Yes.
But the difference between pods and containers wasn't very clear.
The difference between pod and container.
Yeah.
Okay, so I would say container is a kind of physical thing. It's a virtual thing, but container is your packaged application, right? And pod is something that technically doesn't exist. So what Kubernetes does, Kubernetes just deploys your 3 containers. But Kubernetes does not work on containers. It works on the whole pods. So the pod is like unit of work for Kubernetes. The pod technically doesn't exist. It's not something that exists, right? It's not something that you have or you can package or something like that. Pod is just a group of containers. So it's a way of grouping containers.
It's totally up to Kube how they are grouped?
No, it's up to you, up to developer. So developer always defines the applications that are inside. And let me think of example when you want to group containers. Usually you group containers, as I mentioned, for example, if they need to have the same life cycle. So you have 2 applications and they need to have the same life cycle. So it means they need to start together and they need to die together, or they need to work together. If one application needs another one, strictly, then you can or you should deploy them together, right? There is also, for example, this thing. Yeah.
Describe a container as an instance of Docker image. Because that's, I think you didn't specify.
Yeah. So container is the same thing as Docker image, right?
Well, a container is an instance of Docker image.
Yes.
So an image is the definition, and
Yes.
and the container is basically one running.
Yes. So Docker image is your packaged application, and the container is running Docker image, right? So it's the same thing, just running, kind of. Yeah.
There is another magical thing happening there. Actually, the pod is a way to abstract from the underlying, what do you call it, container technology or runtime. In order to be, what do you call it, tech agnostic or whatever, Kubernetes uses the pod to abstract whatever container technology you're running underneath.
Yeah.
In order to achieve all the magic that you showed,
Yeah.
it needs to understand how to actually spin up containers.
And there's one more thing in pods, which are volumes, right? So it's literally in the definition of pods, you also can have volumes. So a pod is this collection of namespaces, Linux namespaces is the technology, to collect all these containers together and provide storage, provide networking to this collection of containers. So it's a logical construct.
Yeah.
Yeah, so
But it's more than containers.
I think
It's more than things.
in practice we'll see that a lot of pods only contain one
Yeah.
container.
Yeah. Usually you will see that 90% probably of your pods will have one container inside. So that was like a kind of future-proofing your experience and your journey in Kubernetes. Yeah.
Yeah, one more is secrets. Are they available to the whole cluster?
No, they are available to things that I also did not mention. They are called namespaces. So Kubernetes is split into also kind of logical divisions called namespaces, and you deploy your applications or your pods to namespaces. For example, here I can show you that I used the default namespace for the whole demo. So if I kill this one, let me kill this one. So there's a few namespaces here already, and we used the default one. So we deployed our application to default namespace, and the secret to default namespace, and the config map to default namespace. And if you want to, let's say you don't want to share your secrets with another team, that's usually how you do it. So you create another namespace called team 2, I don't know, team B, and then you deploy the other things, the other applications to the other namespace. Yeah.
Who's taking care of distributing the images to the worker nodes? Is that Kubernetes, or should you just do it yourself? Always have.
So what Kubernetes does, Kubernetes. What happens, now we are going into details, but we can go, sure. So when you do kubectl apply, right? When we did kubectl apply deployment, this thing, deployment.yaml, which is this file, right? It has definition of your image here. And this is the place where Kubernetes knows where to fetch your image. So what Kubernetes does, it will define that your application will run, your pod will run on node 1 or node 2, right? When this happens, when the decision is made, the node will pull the image from this location. This is Docker registry or something else. So there is no distribution of images across nodes. Its specific node pulls the image when needed, and then it caches the image when needed. So the mechanism, it's a little bit complicated, but it's optimization simply. Yeah?
So I'm not a backend developer, but the question is, where is the data? All the pods are stateless. You can kill them and move them, but where is data stored?
Yeah, ideally, pods are stateless. That's the easiest. Because if you want to keep the state in your application, inside your application, like in memory, then that's also on developer side. So developer needs to make sure that, for example, if one of the pods dies, you need to do something with the data, right? You need to have data redundancy, so you need to either have it the copy of the data in the other, and you also need to make sure that, for example, that the data is consistent across pods, right? So those are all development challenges that you need to take into account if you want to have stateful containers. But in general, it's best to keep them stateless, and it's best to, for example, use external databases. So in practice, what we see is that we run stateless workloads or stateless containers on the Kubernetes, and then we use something from a cloud provider that's managed for us, right? So, for example, we have applications here in Kubernetes, but then there is this database like AWS RDS, or what do we have in Azure? We have Azure Postgres server or something like that, right? And then you basically delegate this to Azure, so that Azure needs to take care of the state of your application, of your database, right? And then if the database dies, it's an Azure problem and not my problem or your problem. So, and it's much less likely to happen, of course, because Azure has thousands of engineers working on that, and you have probably, or you will have 10 people working on Kubernetes clusters. So usually we see that people tend to use managed services for storing state. Some exceptions are Redis, I guess, because Redis, if you use Redis as cache specifically, and if you can live with data loss, because also what can happen, remember that what you need to understand when you start running your applications in Kubernetes is that your application can die at any time, and you as a developer need to prepare for this. So you need to develop your application for this. So which means there are scenarios that I did not showcase today, like for example, you add a new, your Kubernetes cluster, the machines scale. So there is a new machine in the pool, right? And Kubernetes will try to, for example, rebalance the workloads. So they will try to rebalance the application so that all are equally utilized. And then some applications will be killed and they will be moved somewhere else or started somewhere else. I'm speaking moved, but what's actually happening is they will be killed and the new one will be created somewhere else. So you need to remember when you start working with Kubernetes that your application is never safe. It can always die or be killed and rescheduled somewhere else. So, yeah, so basically that's it. So I don't recommend running stateful workloads unless you really need to. Yeah?
Yeah, but the question, when would I want to use Kubernetes versus not, or using maybe a simpler managed container orchestration solution?
What kind of managed container orchestration?
something in the cloud, but you can also deploy containers without Kubernetes.
Yeah, so let me start with this. That's a good point. So you can run Kubernetes as managed service as well, right? On Azure, AWS, Google, there are managed services that will do, for example, they will manage master nodes for you, which means that you don't need to, and also kind of semi, they will manage the machines for you, which means that if a machine dies or something happens, you don't need to worry about this, and updates are automatic and all that stuff. So that's definitely one part. So you don't need to run Kubernetes on your data center. That's one thing that I want to clarify. And the second thing, indeed, you have services that are not Kubernetes. They are container orchestration, kind of. And there are different types of container orchestration services because you have simple orchestration services like, let's say, Azure Web Apps or App Services, right? And this is like a single app. You deploy single app and you can scale it up and down as well. But one thing is why usually companies don't do this is that the cost is much bigger when you start having a scale, right? So for one application, it's simpler and cheaper to just run it in an app service. But if you have a whole department with 30, 40, 50 microservices and like 50 developers, it's actually cheaper to hire a couple of SREs and do Kubernetes or manage Kubernetes than just go with app services because it's getting very expensive very fast. So that's one thing. But there are other reasons as well. For example, you need. Let me go back to the slide. So, where is this? This one. So, what Kubernetes does, it gives you, for example, high availability, right? So you can spread your application across zones, like even regions sometimes. So your application is resilient to, for example, data center failures. And with app services, I don't think you can do it, or not as easily, right? And the other thing that you have here, it's unified deployment across company, right? So you can enforce rules. You can have the same type of deployment for every single team in your organization, right? You don't need to create a separate app service or like, yeah, because it gets with app services, for example. I think this is a good example. It gets complicated really quickly because if you have one app, it's fine, right? But then you have another team that has two containers or two applications or three applications, right? And then you need 3 applications, 3 databases, then you try to connect them to the other app service that you created previously. It all gets complicated very quickly, right? And you need to connect this everything manually, basically. So, or somebody from SRE or DevOps team needs to do this for you. And in this case, you have unified way. It's like you can see Kubernetes as a flexible pool of CPU and memory, right? And it basically will scale as you need, and it will scale down when you don't need it. So those are some of the reasons. There are also company-specific reasons. It really varies from company to company. Anything else?
We have one question from someone online.
Oh, online.
What would you say is the biggest pitfall that you run into while working with Kubernetes?
Probably, yeah. Okay, let me repeat the question. So the question is, what would you say is the biggest pitfall that you ran into while working with Kubernetes? So there is a lot of pitfalls. It's a complex system, and it requires a lot of knowledge to really deeply understand what's happening, because I've seen problems in production that were not easy to debug sometimes. So you need expertise, or at least one team with expertise on Kubernetes, which really helps with all the debugging and problem solving, especially when you go deep down into rabbit hole. My colleague Antonio probably can say a lot about problems we had. Biggest pitfall, Yeah, I think the biggest pitfall in general is complexity. There's a lot of complexity. It's not easy to train developers. It's not easy to get everyone on the same page. It's not easy to control that the things that I actually described, like unified deployment, happen. So it's not easy to ensure that all deployments are unified and in the same way and they all use the same structure and so on. It's always difficult in every company. So I think that's like the general thing. But we've also had very specific problems with Kubernetes, like networking is very difficult to debug and very time-consuming to debug some things with networking in Kubernetes, especially if you don't have good overlay network on it. And we had situations when, for example, pods would die and we couldn't figure out why. So this also happens. And then you need to spend some time, actually, sometimes an hour, sometimes a day, it depends, to figure out what's happening. And sometimes there are weird corner cases, which are not specific to Kubernetes per se, but the whole ecosystem of Kubernetes gets really complicated right now because you have Kubernetes, then on top you have service meshes, you have policy agents, and you have a lot of things that you can deploy these days to Kubernetes, and some things people regard as must-have. So all of this makes the whole landscape complicated. And if you don't have very experienced team to manage this, it can go, it is dangerous, yeah. So thank you for the question from the audience. And thank you everyone for